Hi everyone, Gunnar Grosch here, back with another video. This time we're gonna talk about blast radius containment when using chaos experiments. This time I'm coming to you from the living room, but sorry to disappoint you, Ricardo, we will not be building spaceships this time. Instead, we're still focusing on chaos engineering and on serverless environments. So, last week we did a video where we did a simple chaos experiment. We had this environment, which was quite basic serverless app, an Amazon API gateway and two functions behind that one, which in turn then were connected to a DynamoDB table. We added latency into one of the functions to see how the applications would react. And more in detail how we did it, we used the chaos injection layer that Adrian Hornsby has built and added that onto one of the functions. We then had a parameter in parameter store where we were able to enable and disable the latency injection and also configure how much latency we would add. And then in the function code, we were able to define and call delay as we wanted it to in the latency function. So then what if we have a larger application, serverless application? In this case, we have one that contains of 4 functions. Because in the previous one, it was quite easy. We had 2 functions. We knew that we wanted to inject latency into one of them. But that's usually not the case when you're working with chaos engineering. You want to test all parts of the system. So in this case, we have 4 functions, and I would like to try each and every one of them to add latency into every function to see how does the application behave. I can switch over to the application and show you just what it looks like. Still really simple web application. In this case, we have the 4 functions. Each function is called 3 times. And the numbers you see in this case are just the execution time of each function. So for each execution for each function, we get the timing of them shown on the page. So if we did the same thing as we did last time, we add the chaos injection layer on each function, we add the parameter in parameter store, and we add the functionality into the code for each function, we would get this behavior. Because since the parameter just says to enable or disable, we would inject latency into all functions. And that, of course, would create something that perhaps isn't what we really want, because then we're not able to see how does the application behave if function 1 has latency or if function 3 has latency. We can just try it out to see what it actually would look like. So this is the parameter that we have in parameter store. At the moment it's disabled, but I'll just change the value to true so that it is enabled, and then switch back to the application. As you can see, now we're injecting 500 milliseconds of latency into all 4 functions at once. Once again, this is probably not the way you want to do these types of experiments. So blast radius is something that's key when using chaos experiments. As the principles of chaos says, experimenting in production has the potential to cause unnecessary customer pain, because we are actually doing experiments in a live environment. So even though there should be allowance for some short-term negative impact, the chaos engineer must ensure that the fallout from experiments are minimized and contained. Well, looking at the previous one, I would say that those experiments are not minimized and contained. So we have to design the smallest possible experiment to effectively test the system. And by starting small, even if things go wrong, that is that the experiment that we perform creates an outage. It creates a problem with the application. So by starting small, we shouldn't cause an outage. And it is, of course, key to understand how failure plays out. So we're able to scale up as we gain confidence in the system. So we start small and we grow the experiments. So what I want to do is something more like this. I want to be able to add latency into each and every function separately. So that instead of injecting latency into all functions at once, I'm able to control to inject into function 1, function 2, and then perhaps as confidence grows into function 1 and 2. So to do this, I'm going to start by forking Adrian Hornsby's LatencyInjectionLayer repository. And then I'm going to add support for separate parameters per function. Then, while at it, I'm going to make the layer easy deployable by using the Serverless Framework. When that is done and we have a layer in our environment, we can then update the Serverless Chaos demo app, the large one, with the new layer. And then we add parameters for each function. Then, of course, we try it out and perform some chaos experiments. Okay, so I have already forked the repository from Adrian Hornsby. I have cloned it, I have created a virtual environment, and I have installed the requirements. So let's jump into the code. In the folder that's named Python, we have the Python file containing the code for the layer. So, and as we can see here, there is a parameter from parameter store that's hard-coded in the code, chaoslambda.config. And this is what we want to replace now, because since we want it to be configurable on a per function basis, this needs to be a variable instead. So I want to use environment variables so that we're on each function are able to configure what parameter to use. So let's go ahead and change that. We'll import OS, remove this, and then we just use this, and let's give it a name, latency injection param, like that. Okay, stored. So each time this code gets called, it will then use the environment variables on the latency or on the Lambda functions and look for latency injection param and see what parameter to use. So that's cool. Then, as I said, I want to make it easier to deploy the Lambda layer. So by using the serverless framework, we're able to do it quite easily. So let's create the template file for that, serverless.yaml. Already have the top part of that. Let's name the service latency injection. And we're using framework has to be newer than 1.34. The provider, of course, is AWS. So then we have the information regarding the actual layer. Let's call it latency injection. Okay. The path for this, of course, is the entire folder we're in. Let's add a name, and I like to do it this way. So we get the service name, which in this case is latency injection, and then to add the stage we're in, so that we're able to deploy to different stages. There we go. Okay, we choose the runtimes. In this case, I know it's Python 3.7. And then we have the option to choose if we should retain the older versions of the layer when updating it with a newer version. And in this case, I think it's smart to do it that way. Then we're able to add new functionality into the chaos injection layer, but still have functions that's using the older version as well. So let's set retain to true. And this is more or less it, but I want to add the package command as well, so that we're able to choose what to include in the package. Otherwise, when Serverless Framework deploys this, it will use everything that's in this folder. And that means that the zip file will be larger than necessary. So let's exclude everything and then just include what we want. And in this case, that is the Python folder and everything beneath that. So we're excluding everything but including the Python folder. So let's try to deploy this. I'm just gonna make a quick change on the service name. Then we use the Serverless Framework to deploy. I want to set the region to Ireland in this case. And the stage can be dev. So let's kick it off and just make sure to see that it gets started. So it's beginning to package the service. So everything looks good so far. So while we're waiting for that to finish up, let's jump over to our to-do list to see where we're at on that. So we started by forking Adrian Hornsby's LatencyInjectionLayer repository to be able to make the changes that we want. And in the code for that, we changed from having a hard-coded parameter name into using environment variables so that we're able to use separate parameters per function. So that in the environment variable, we'll put a name that points to a parameter. And we also wanted to make the layer easy deployable by using the serverless framework. So we just created a serverless.yaml file. And then of course we need to make sure that we have the serverless framework installed. Then we're just able to deploy it if all goes well. Next step then is to update the demo app to have the functions in the demo app using the new layer. And of course we then need to add the parameters for each function. When we've gotten that far, then we're able to perform a new chaos experiment. So hopefully all goes well. So let's see. We've been able to create the stack, and the zip file has been uploaded to S3, and the template is validated. Now we're just waiting for the stack update to finish up. So we'll see if the Lambda layer is... There we go. And so we can see that it has been deployed. LatencyInjectionLayer dev version 1 is now deployed into Lambda. So let's go to the console and see. There we go. There we have our new layer with the ARN pointing to version 1. Cool. So now I've switched to the demo app in Visual Studio Code, and it's time to update that so we're able to use the new layer and then get the parameters that we want. So let's just open up the serverless YAML file there and have a look at it. And as you can see, on the functions we have defined here, we already have the old chaos injection layer that we used. So now we want to switch this out to the new one. So let's just get the reference for that. switch it out on all 4 functions. There we go. And the next step then is to add parameters for each and every one of these functions. So we'll add those as resources in the YAML file. So we'll just create one for each function. There we go. And these should then be of the type AWS SSM parameter. Properties are quite simple. We'll give it a name. Use the service name to begin with, and then just name it after the function, perhaps. The type is string, and the value should be the same as we have in the other parameter to begin with. So, we'll add the delay 500, and then is enabled should be false. There we go. That looks correct to me. So this is the first one. And since we have 4 functions, let's add 4 of these. Number 2. Number 3. And number 4. Cool. So, if this works as intended, we should now have updated the functions to use the new Lambda layer. We have added parameters for each function. Now we need to make sure that each function also has the environment variable to be able to get the correct parameter. So let's add that as well. Environment. And we call that one latency injection param. And here we can just make a reference to the parameters that we have created, the different ones. So I was at function 4 right now, so function 4 parameter, and that should be it. Let's just make the same changes on the other ones. Function 3, function 2, and function 1. There we go. And the last part then is to make sure that the Lambda functions are able to access the parameters. Previously we had allowed access to the chaos-lambda.config parameter. Now I want to change it so that they instead have access to these new parameters. So let's do it this way. Let's just add the service name, and for now a star, so that all parameters that has the service name to begin with are allowed to be read. Great. So that should hopefully be it. So this is the exciting part. Let's see if these changes works. So SLS deploy region US1. Let's start the deployment. Wait for, there we go, it's starting. So in the meantime, let's switch over to the to-do list and see where we're at. So now we've updated the Serverless Chaos demo app with the new layer. We added parameters for each function in the serverless YAML file. We've given permissions to read the new parameters, and we've also put environment variables on each function referencing the new parameters that we've created. So if all goes well, we should be able to see the new parameters quite soon in the console. So let's just wait for the update to finish. Switching over to the AWS console now, hopefully we'll be able to see. There we go. So our 4 parameters has been created. Let's look at them. Yes, and the value seems to be correct. Awesome. Looking at the Lambda functions as well, they are modified recently. They have a layer, and the layer is our new latency injection layer. That is cool. So seems like the update worked. So now I guess it's time to test the application. So this is the demo app running with the 4 functions, all using the new Chaos latency injection layer. And as you can see, it's running as it should, since no latency is injected at the moment. But now it's time to do a Chaos experiment and try to inject latency into one of these functions. And as with the last demo, I'm just going to update the parameter using the CLI. So as simple as possible, and that's also a good way to have an easy way to stop the experiment if something goes wrong. So we're using AWS SSM put parameter. What we want to make sure to do now is to change so that we're using the new parameter. So let's check the name. This is the name for parameter to function 1. Here we go. And now delay 500 and is enabled should be set to true. Let's try to line this up so that we're able to see as we're changing. Okay, there we go. So changing, and there we go. We have added latency into function number 1. So now function number 1 runs a lot slower than function number 2, 3, and 4. That is cool. So now we're able to inject chaos into one of the functions instead of all 4 at once. Let's change this back to false. And hopefully it should, yes, our stop button works. We're able to stop the experiment just as easily as we're starting it. That is cool. So let's just try it once more. And this time let's add 2000 milliseconds, and let's do it to function 3 just to make sure that it works. So now function number 3 should be a lot slower. There we go, 2077, 92, and 94. That is awesome. So now we're able to inject latency into each and every function. That is the purpose of all of this. It's been a long video, but we've managed to do what we set out to do. And that brings us back to this slide about containing the blast radius, which was the whole point of all of this. So we have now been able to perform experiments where we have contained the blast radius so that we're not making an experiment that's larger than intended. We are not having a complete outage, we are just testing the functionality that we want to test. So remember this, design the smallest possible experiment to effectively test the system. Start small so that you don't cause an outage. And the purpose is to understand how failure plays out so you can scale up when confidence in the system grows. So thank you very much for watching. It's been fun trying to do some more chaos engineering experiments on a serverless environment, and this time we looked specifically at containing the blast radius. So keep your eyes open, more videos coming up. Okay, thank you very much.